Okay, today we're going to be talking about different types of sampling. So we already talked about one the other day, simple random sampling. So we're going to retouch on that and then learn about three additional ways to sample. So a quick note, for the Google Meet today, we're going to be doing kind of a hands-on, in quotes, practice with these different sampling methods using an activity on Google Slides. So hopefully when we get to that point, you'll be able to kind of stay on the Meet and follow along and do the activity your own on Google Slides as well. So just keep that in mind. We are going to be doing more examples of these different sampling methods and not just what's in the notes right now. Okay, so first we're going to retouch on simple random sampling. So again, this is just when you have your entire population, everybody gets a number, and then you use the random integer generator on your calculator to randomly choose your sample. So though this is the best method, it's always nice to just be simple random. The method is not always possible just based on the population you're trying to gather data from. Sometimes it's just not feasible to have everybody to choose from, though if possible, simple random is a really good method to use. So a refresher on how we perform a simple random sample. You number each individual in your population from 1 to n. Remember, this capital N is your population size. So let's just say we have these dots here. Let's say we have 5 dots. So, and that's our population. So we'll number them. And then we're going to do a random integer generator in, first we got to input the seed, sorry. We're going to input our seed into our calculator, which will always be given to you. Let's just use a seed of 7 for right now. So a reminder of how to do the seed. So for this seed, you type in whatever the number is that our seed is, so 7 in this case. And then you hit the arrow down here, the stow with the arrow, so it pops up. And then you go to Math, over to PRB. You select that first option, Rand, hit Enter, Enter. The seed should pop up as your answer, and that's how you know your seed is set. And then we're going to do a simple random sample using our random integer generator. So we hit Math again, go over to PRB, and select option 5 now, random integer. And then the numbers that go in the parentheses, it's always 1, comma, and then however big your population is, so however many things you have. In this case, we numbered 5 dots, so it'd be 1, comma, 5. Okay, and then depending on your sample size, let's say our sample size was 2, that means we would want 2 of these dots in our sample, so we would hit Enter twice. And so we would take the second dot and the 5th dot as part of our sample. Okay, so second dot and 5th dot. So these two are the samples. So again, lowercase n here is our sample size. So that's just our sample. The ones that we're choosing for our sample is number 2 and 5. Okay, so now learning some different methods of sampling. First, we have systematic sampling. So systematic, the name, it kind of implies there's like a system or there's a rule that we follow. And so this type of sampling is when you put your population in an order. It doesn't matter what order. It can be random. It does have to be in some sort of order or like a line. And then you're going to choose a random starting point, so that's where the randomness comes in. Every one of these sampling methods has some method of randomness, and you are going to be doing a simple random sample within these other methods that we're talking about. They're just a little bit more involved. So you are going to be choosing a random starting point, and then you're going to take every kth. K is a number that we will learn how to calculate in a second, but you're going to take every kth individual for your sample. So for example, you would take every 5th person or every 25th person. So that would be the rule that you're following. You're counting the same number of people every time, and you're taking every 5th or every 25th or every 6th or whatever it is person for your sample. So one note about this type of sampling is it does not require a frame. A frame, remember, is the list of your entire population. So it is useful if you can't get a list of your entire population. Like if you want to sample everybody that goes into Walmart on a given day, you're not going to know ahead of time every single person that's going to go into Walmart on that day. So this is where systematic sampling could be helpful, because you could just say, okay, well, I'm going to talk to every 17th person walking into Walmart. So this is why it's like I said, simple random is great, but it's not always feasible. Okay, so how to perform a systematic sample. If possible, you're going to approximate the population size. It doesn't have to be perfect. We just want to get a good enough approximation. So again, remember that capital N is the size of your population. And you're going to determine your desired sample size, lowercase n, so just how many people do you want in your sample. Let's say that if we're talking about the Walmart example, let's say we can estimate that there's going to be 2,000 people going into Walmart that day. And we want to sample 500 of them. Actually, that's too many. Let's do we want to get 150 people to sample. So first, we need to determine the rule. We need to figure out what we're going to be counting by when we're standing at the door of Walmart watching the people go in. So again, this is called the K value, the rule that you're following. So to find the K value, you just take your population divided by your sample size. And then this little important tidbit here, you're always going to round down. That just makes sure that you don't run out of people before you've reached your sample size. So that's why you're always going to round down when you're calculating K. So for our example, we would have K equals our population of 2,000 divided by our sample size of 150. And when you do that division, you get 13.333333 repeating. So I'm always going to round down. So we'll have K equals 13. So that means we're going to take every 13th person. So even if I got 13.999999999, you would still round down to 13 to have your K value be 13. K, you always round down. Okay, so we know what we're going to be counting by, but now we need to determine our starting point, which is the letter P in our population. We need to figure out where to start in all these people walking into Walmart. So this does have to be random. It has to be a random starting point. You cannot just always start with the first person whenever you do a systematic sample. So we have to find a random place to start. This is where that element of randomness comes in. So you're going to set your seed, which will be given to you. So let's use a seed of 26. So again, to set your seed, you type in 26, hit the stow button with the arrow, math, PRB, and then select that first option, rand. Hit enter again, so 26 shows up on your screen as the answer. And then to pick your random integer, to find your random starting point, you're going to do math and then rand int, option 5, over to PRB menu. And you're going to do 1, comma, whatever your K value is. You're going to be starting in between, somewhere in between 1 and 13, just randomly. Okay, and so when you do that, math, go over to PRB, select option 5, rand int, 1, comma, 5. You hit enter once, and that gives you 2. So this means we're going to start with the second person. So start here. Then you're going to count every 13th. So start with the second, then take every 13th person until you get to your 150. So we're not going to write all 150 people we're going to do, but we're just to get an idea. So again, we start with our second person. And once we get that 2, once we get that random starting point, we no longer need to use the random integer generator in our calculator. We're just going to count. So now every 13th person. So 2 plus 13 is 15. So we take the 15th person. 15 plus 13 is 28. So we take the 28th person. 28 plus 13 is 41. So we take the 41st person, and so on. So you keep going and going and going until you get 150 people. Okay? So now we have a cluster sample. So systematic, following a rule. Cluster sample is when we divide our population into clusters. They're just random groups, little clusters of people. They don't have to have anything in common. And you're going to number each of your groups. So group number 1, group number 2, group number 3, and so on. You're then going to use your calculator to randomly choose. There's your randomness. We're going to randomly choose clusters. We're going to randomly take groups and take all the individuals in those chosen groups. So cluster is where we have groups and randomly choose groups and take all the individuals in that group. Okay, so this is a good sampling situation when it's necessary to kind of speed up the data collection process, because you can just do groups at a time and having to hunt down specific people. So how we perform a cluster sample, you're going to put your population into clusters first. You're going to put them in those random groups and number each cluster. So let's say we have a group here, group over here, group over here. And all your clusters don't have to have the same amount of individuals in them. It's helpful if they're around the same size, but it doesn't have to be exactly the same. Then we number each group. Let's say we want a sample size of 15. We're going to input our seed. Let's use a seed of 21. So input your seed, 21, use the stow button with the little arrow, math, go over to PRB, select the first option, rand, hit enter, your seed is set. And now we need to randomly choose entire groups. So instead of typing in 1 comma your total population size, here with our random integer, math over to PRB, rand int, we're going to do 1 comma the total number of groups that we have, which in this case is 5. And then we hit enter, and we get group number 4. So group number 4, we're going to take all the individuals in group number 4. And so group number 4 had 1, 2, 3, 4, 5, 6, 7 dots. So we're not yet at 15, so we got to pick another group. So you hit enter again, and we got group number 5. Group number 5 has 1, 2, 3, 4, 5, 6. And so 6 plus 7 gives us 13. This is where it's kind of up to you whether or not you want to pick another group or not, because if you pick another group, you're going to go over your sample size. If you don't pick another group, you're going to be a little bit under. It's always better. More is always better. It's better to have more people in your sample than less. So I'm going to go ahead and pick another group. So you just hit enter again. And I get 3. So 3 is our other group. Okay, and so now all these individuals, the yellow dots, all the green dots, all the black dots, all of those are going to be part of our sample. So sample is all of groups 3, 4, and 5. Okay, so cluster, you randomly have your groups, and then you randomly pick groups and choose everybody from each of your chosen groups. Then our last one here is a stratified sample. This is where we separate our population into non-overlapping groups called strata that share some similar traits. So cluster, all of our groups could just be random, it doesn't matter. Whereas with stratified sampling, our groups have to be based on something that they have in common. So like you can do males and females, freshmen, sophomores, juniors, seniors, something like that, where there's something in common that your groups have. Then you're going to obtain a random sample from each group. So this is a way to make sure that different groups in your population are equally represented in your sample. So stratified, you're picking some from each group. Cluster, you randomly chose some groups, other groups you totally left out. Stratified, you're going to select some from each group, and every group is going to be represented. So This method allows for fewer individuals to be surveyed while still having the same or more information, since individuals within each group have similar characteristics and you're getting a representation from each of the groups. So how to perform a stratified sample. First, you have to determine your groups. Your groups should all be based on some similar characteristic again. So let's say we have some guys over here, males over here. So we have 5 males over there, and we have say 3 females. So we have females and males. And we first need to figure out the proportion, or how many people we are going to be taking from each of these two groups. So to do that, you take the number of individuals in the group, so in this case 5 males, divide it by the total number of people in the population, so the 5 males plus the 3 females is 8. Then you're going to multiply by your sample size. Let's say we want a sample size of 3. So we multiply by 3. These seeds and sample size, I'm just coming up randomly. You don't have to know how to come up with them on your own. All right, and so then you do 5 divided by 8 times 3. That gives you 1.875. In this case, you can round normally. So 1.875 will round to 2. So we're going to take 2 males. Now we do the same thing with the females. We have 3 females out of the 8 people total, times a sample size of 3. Do that in your calculator. 3 divided by 8 times 3. Get 1.125. 1.1 would round down to 1. Okay, so this one you round normally. So nearest whole number. Remember with the K value in systematic, we always rounded down. In this case, you're just going to round to the nearest whole number, round like you normally would. Okay, then you're going to input your seed. Let's use a seed of 33. So you do 33, stow, math, PRB, rand. And then you're going to do 2 separate simple random samples. One for the males to pick your 2 males, and one for the females to pick your 1 female. So for the males, you'll have rand int 1, 5, because there's 5 males to choose from. And then you're going to hit enter 2 times because we want 2 males. So you're going to take male number 4 and male number 2. Oops, 4 and 2. Then for the females, you're going to do rand int 1, 3 because there's 3 females. You don't have to re-input your seed either. So PRB, rand int 1, 3. And we get 2, so we're going to take our second female. And then that is your sample size. 2 males, number 4 and 2, and 1 female, number 2. So these 4 sampling techniques that we've worked through, simple, random, systematic, cluster, and stratified, they're all unbiased sampling, which is the best kind. And this is because there's an element of randomness to each method. So often sampling methods are used in which the individuals are not randomly selected, and these are examples of biased sampling. So this is one example of biased sampling. It's called a convenience sample. This is when individuals are easily obtained or if they're given a choice to participate. So if you're being lazy and just asking people around you, just asking your friends or family, or if you're emailing out a survey and letting people choose to respond or not, that is going to be a convenience sample, and it's not always going to give you the best results. So since it's a biased sampling method, this is not the best method to use and should be avoided if possible. So you should always try to use one of the other methods that we learned up here, one of these 4. I can count 1, 2, 3, 4. One of those 4 sampling methods instead of convenience. So here I have just a little decision tree to kind of help you identify the difference between these sampling methods. So the first question you need to ask yourselves is, do the individuals have a choice, or were we lazy in who we asked? If the answer is yes, then that is convenience. And that is the biased sampling, which is not the best one. If the answer is no, then that's when we have our unbiased, which is the best. So then once we know we're in the unbiased section, then we need to ask ourselves, is our population being divided into groups? If the answer is yes, we are dividing people into groups, then cool, we go over here and we ask ourselves, do we take all the individuals from those randomly chosen groups? If we're taking every single person from the random groups we choose, then that is a cluster sample. If we're not taking all the individuals from the chosen groups, that's the stratified. That is where we take some from each group. Okay, so if we go back up here, is our population divided into groups? The answer is no, we're not dividing our population into groups. Then we ask ourselves, okay, well, are we following some sort of rule or system, like every third person or every fourth person starting with the third? If the answer is yes, then that is systematic. And if the answer is no, then that means we're simple random. All right, and that is it.